is the principal automation architect at Magenic. But more than that, or even if he wasn't that, he would still be a great speaker, an incredible author. And if you ask me, one of the leading experts on most of the stuff that it's important around automation. And I love listening to his sessions because I really learn a lot from them. So I'm honored on having you, Paul, here, and I'm going to be learning about parallelization in automation and how to make it right. So the floor is yours, man. Go ahead.
All right, thank you. I can't seem to get my camera on. I think you
wait.
have to enable it.
Yeah, I did it yesterday, but apparently it's not enough. Give me a second, and I'll tell you when I've done it so that you can do it. But you can get started. Don't worry.
All right, let me share again. All right, good morning, everyone. Good evening, depending on what part of the world you're in. Thank you for taking some time to join us today. So we're going to talk about preventing your automation from stepping on its toes. And we'll talk a little about what I mean by that. So who am I? Joel's done a great job of introducing me. I am a principal automation architect now at Cognizant SoftVision, formerly Magenic. SoftVision purchased us back in February, so we'll be rebranding stuff, and you'll notice different branding on the slides. If you've ever looked at my slides before, I've spent my career focused on automation for oh wow, very long time now, over 25 years. I did a stint as a director of QA for a while, which was cool. I enjoyed doing that, but automation is really my true calling. I'm the advisor to a couple of different organizations, and in case you're interested, and if you can see it, the new Halloween single is very, very good. Check it out. So if you want to get in contact with me outside of this particular forum, here is my contact info. And that link at the bottom there is where I blog. And that's where I put my mostly cogent and sometimes not so cogent thoughts down. So stepping on toes, what does that mean? And when you step on your own toes, that means when you're not really paying attention to what you're doing and you accidentally hurt yourself, right? You do something that that injures yourself, or at least isn't really comfortable. And we can do that with our automation as well. Why? Because we want to go faster. We want to have a higher throughput of our automation. But to borrow from the Boromir internet meme here, one does not simply walk into test automation and parallelize it. There are considerations, otherwise you will step on your toes or have possibly worse, you'll cut your toes off. So what could happen? Mostly what could happen is you would have intermittent failures where we say, hey, look at our test run. Awesome. We got 3 failures and 3 passes. 50%, that's not good. Let's go investigate. Everything looks good. Let's run it again. And we run it again and get different results. And I know most of us are familiar with this from, say, unhandled race conditions in our test scripts, or sometimes unhandled race conditions in our application that we're testing. So we have to be mindful of these types of items as well. But we can cause these types of issues, these intermittent issues, and sometimes consistent issues, but usually intermittent issues to happen if we're not careful with how we implement parallelization or concurrency. Well, I'll use the term sort of intermix there.
Paul, 1 second.
Yes.
Just found the button I was looking for. You can.
Okay.
Yeah, sorry for that.
No worries. Oh, there it is. Start video. And hey, look at me. Hey, I'm even wearing my gear. Look at that. Check it out.
Yeah. Hey, I'm green with envy. You know that you guys actually had one. I'm wearing like a shirt because I didn't get mine. Heads are gonna roll here. I'm telling you. Go on.
No worries. So with apologies to Pink Floyd. So careful with those toes, Eugene, because you will step on your toes if you just go in and say, turn on parallelization or concurrency and threading and we're good. You'll step on them or you may actually cut them off if you're not careful. So be careful with the axe that is parallelization. Oops. Too many technologies. Here we go. So One of the main parts of going parallel are the notions of threads and concurrent processes. So what are threads? Many of you already know this. Some of you may not, or you may not understand what the underlying implementation is a lot of times when we do turn on parallelization. So a thread is a lightweight way to run stuff at the same time. A lot of times, if you want to run things two at the same time, you would run two of them, but that's a very heavyweight way to do it. Turning on parallelization at your tool level, your framework level, or your language level enables these lightweight, they're called threads of execution, to execute through the same parts of the code, but independently, or sort of independently, right? The execution flow is independent, but part of the power and the speed that you sometimes can get through threaded communication is the fact that you're sharing data, actually sharing data and data structures that are in your program. And in this case, that program is your test script or one or more of your test scripts. It's very powerful because you can get this parallel or parallel-like execution through this threaded environment, but it is problematic because the code you write and the code you use must be thread safe. We'll talk about thread safety on the next slide, but it must be thread safe. Otherwise, you will start seeing intermittent issues, everything from just data corruption to intermittent pass fails to actually potentially even, depending on what language and sort of constructs you're using, you might even crash your program, get some assertions or exceptions being thrown. And even outside of these shared internal data structures, you may have dependencies on external entities as well, such as databases or file systems or just pieces of equipment even. So we have to take care and understand what our individual test scripts are accessing, what they're accessing internally through the system, and then externally in our product as a whole or in our test bed as a whole. So similar to threads, but much heavier is concurrent processes. And I've implemented this concurrent process stuff many, many years ago because the threading technology wasn't as advanced as it is now. And we also had some problems programming at the threading level because we were just starting out, and programming at the thread level can be difficult if you don't understand all the considerations, and we didn't at the time. So it will definitely eliminate some dependencies, because if you go with concurrent processes, in other words, I've got a completely separate entity running test script 1 versus the one that's running test script 2, you eliminate that shared internal data structure problem, but you still have the external entity dependencies that you have to manage and deal with. And that's mostly what the rest of the talk is going to be about today. And this is not what's typically done today. This would be sort of the corner case, your 1% case. Mostly things are implemented with threads or thread-like implementations for the different programming languages and frameworks that we use these days. So when I talk about thread safety, what am I talking about? Thread safety is the safe manipulation of shared data, just at its core. Shared data, and when I say shared data, I'm not talking about shared data in a database. That's handled differently, and we'll get to that in a second as well. But I'm talking about shared data internal to an execution entity. So in this case, if all of your test scripts write to a shared file, a shared results file, that would be shared data. That would be a shared data structure, because you're all going to access that through some sort of file handle or object in your program. That needs to be handled safely. That needs to be handled in a way that is thread safe, and you're not going to corrupt the data or get it to some sort of state where one of your writes fails because another write is going on to that same file at the same time. So there are some general methods that we can employ, and I can't get into all the details here because just, with 30 minutes plus questions, I just can't get into these. Each of these could be an hour or more on its own, really. So reentrancy. The idea of reentrancy is the fact that a particular function, a particular routine, could be executed by multiple threads all at the same time. Well, how would that happen? A lot of times, the way the threading systems will work is if your routine blocks, it's waiting on some sort of resource to become available. And we're not talking about a multi-second block most of the time. We're talking about, oh, I need to do a write to a file or access a database. Well, there's some round trip time there that has to happen for that to happen. It may even be in the milliseconds, depending on what you're doing, maybe even sub-millisecond, depending on what you're doing. But the threading system may take advantage of that to saturate the processing capability and get you as much throughput as possible. So it might call another thread that also wants to execute that function, that routine. If your routine, your method, your function is not reentrant, you can absolutely have data corruption that way. And there are ways to write reentrant code. It's not always trivial, so it's not always for the faint of heart. And I would not say that it is a basic sort of an introductory level approach to programming or test script implementation. Immutable objects, on the other hand, are something that we can absolutely do. So immutable means unchanging. So if at the beginning, before you do any threading, or even outside of the threading aspect, if you set up a data structure internally, externally, whatever, such that it is immutable, that it is not going to change, it's only going to be read, then it is thread safe just by its nature because nothing's changing it. Therefore, there's nothing really that's going to have a problem accessing it, unless concurrent access is a problem. Pardon me. So concurrent access can be managed through something called a mutex. And a mutex is a portmanteau of mutually exclusive, meaning that only one thread or one concurrent process can access a particular resource, a shared resource, at any one given time. The traditional sort of idiomatic way to implement this is through something called a semaphore. And a semaphore can either be up or down, locked or unlocked. The idea is that, hey, I am going to access this particular shared resource that has to be accessed sequentially. I am going to lock that resource, which means any other thread or concurrent process that wants to access that particular resource also has to try and lock it. If it can't, it either fails the lock and it gets an error, or it lines up, it queues up and waits for its turn to access that mutually exclusive resource. Then when the one that had the thread that has it locked unlocks it, it becomes, or is finished with it, the thread unlocks it, then it becomes available for the next requester to establish a lock. There are some challenges here. Because you're working distributed across multiple different functions potentially and multiple different threads, it may be hard to keep track of who has it locked and did you unlock it and what state is it currently in. Code review is very, very important for this kind of thing. And the smaller you make that block of code, that routine around the mutual exclusion, the easier it's going to be to implement, test, and maintain, because it's all right there where you can largely see it. You don't have to worry about as much of it being distributed across. Another problem you can get into is something called deadlock. And deadlock is basically the idea where there are multiple mutually exclusive resources available and a particular thread wants more than one at a time. Well, if there are three and thread one gets two of them and thread two gets the other, and they're each waiting on the other to release it, they get into deadlock because they're both waiting for something that's not available, and they're not going to release theirs until they get the other one and can use them all in conjunction. So managing that can be difficult. So deadlock is definitely something you'll want to read up on, research and understand the ways to prevent deadlock, avoid deadlock, and even break out of potential deadlock if you find yourself deadlocked. And one of the final ways, and there are other methods outside of this, but I just chose a few of the ones that are a little easier to talk about. Atomic or non-interruptible methods. So from a atomic method standpoint, we talked about reentrancy. Reentrancy would say, hey, if I get blocked, then go ahead and you can run another thread. Atomic methods would say, if I'm in a method that I designate as atomic, non-interruptible, then what that means is that don't interrupt me. Even if my thread blocks during this, don't interrupt me because I'm doing things in here that are potentially destructive or disruptive to the state of the system. If I'm interrupted, the system and state will get corrupted and we're going to have problems. And different languages have different mechanisms to designate methods or sections of code as non-interruptible. Fortunately, we don't have to be like super geniuses on all of the aspects of these things. There are thread-safe data structures, thread-safe libraries, thread-safe frameworks, and such out there available. So look for the notion of these data structures and libraries and frameworks being thread-safe before you use them, and only use the ones that are thread-safe. So those are sort of the programming aspects around thread safety. But from a concurrency safety, from a parallelization avoiding of the toes, shall we say, there are other considerations, the external things that we can't manage inside of a single test script per se. So do you have enough credentials? Hey, I want to run all of my tests concurrently. Nah, I don't have enough horsepower for that. Okay, I'm going to run 10 at a time. Awesome. Does your app require logging in? If your app requires logging in, can the same user be logged in more than once? Yeah? Okay, cool. Great, great. So maybe we can get away with one set of credentials here. Oh, but if so, if the same user is logged in more than once and changes the state of some of the data, is the data now corrupt, or at the very least, the state is not sufficiently known such that other test scripts may start failing because the data is not in the state that we thought it was going to be? Excuse me. So perhaps having additional credentials would be beneficial. That way you can run each of your individual test scripts concurrently in parallel and not worry about the user state corrupting each other or stepping on each other's toes. But there is a question there, and that is, how hard is it to obtain unique credentials? So in some companies, it may be very easy. In some product implementations, it may be very easy. If your product, if your application manages its own credentials, where you say, oh, wait, I want to add a user, you go to the app, you go to the administration section, you say add new user, type in the credentials, and boom, you got a new one. And boom, you can just blow it into the database and you've got 20 new ones. Awesome, great. But a lot of products are not set up that way. The access and authorization and all of that of credentials are managed externally through the IT department, through Active Directory or some other comparable product. Now what do you do? Well, now you have to go to an external entity, your security team, your IT team, your network team, whatever, and say, I need 32 or 30 new sets of credentials so that I can access this test environment. Yeah, I'm going to own them all, but I'm going to share the passwords out with the rest of the testing team. Well, after they get up back, sit in their chair, and their head stops from being on fire, they're probably going to tell you no at first, unless they've been through this before, because on its surface, that is a potential security risk, depending on what having an Active Directory or corporate account allows you to have. From just an access standpoint, can you send mails? Can you log into various other systems? It may not be something that could happen at the drop of a hat. and it may take some time. You may have to have several meetings. You will probably have to partner with the team that manages these credentials to say, look, we have a business need. In order to accomplish this business need, we need to run these things in parallel. And in order to run them in parallel, I need X number of credentials. And yes, we have to share the passwords because that's how we maintain these scripts in this particular environment. And there are ways to handle these types of things that are going to be largely tolerable and digestible by security and IT teams, but it's not something that you always can just do. There has to be planning, there has to be some setup. So allow the time for that, allow the effort for that, and know that it may not be quick. And then there's the data. I've talked about data a lot, or at least I've said the word data a lot. And as we know, in testing in general and automation in particular, managing data is a real pain. I mean, it really is. Not all the systems were built to be testable, and not all our systems were built to be automatable. So sometimes the interface to just say, hey, I'm going to run a test script. So I'm going to blow this data in right at the beginning of the test script, and then I'm going to run it, and then I'm going to get that data out of there. The systems aren't set up to do that. The applications under test are not set up to behave that way. So we preload data, or we put data in and we sort of assume and hope that it's in the right state. We tell people, don't go touch that data. That's our test data. When you start talking about parallelization, it's possible, depending on what your scripts are doing, each potentially concurrent script might need its own data, because a lot of the testing that we do for systems, the data tends to be transitive in its state. Think about like an airline reservation system. Well, I'm going to make a new reservation. Cool. Now they got some data there. But then at some point, we may take data and progress it through the, okay, now the flight has happened. Well, you don't have reservation data anymore. And perhaps you have some archived historic data of the fact that you actually boarded the plane, but you don't have that reservation in the same state as it was anymore. So in addition to our normal considerations around test data that we manage well or not so well in most cases, then we've got this additional concept or this additional consideration that is concurrent execution may require concurrent data, or at least discrete data across each of the execution entities. If we don't pay attention to the test data at this level, it can and probably will cause inconsistent behavior. It will also, remember we talked about earlier, that we may actually see some, well, as you know, we didn't talk about that yet. We'll get to that soon. But we may actually see behavior we didn't realize we had, because now we're trying to work on the same data with everything in parallel. Because it could be that test script number 5 accidentally depended on something that was done by test script number 2. But we didn't realize it. It was an accident. It was an oversight. We missed it in code review. We missed it in what we were building. And now test case 2 and test case 5 are running concurrently. So you get inconsistent behavior depending on who does what step and which check first. So data is key here. We talked about data internally to the test, to the script from a threading standpoint and data structures, and then these external entities, the access to these entities and the state of their data or the state that they're actually in. And then there are also execution environments. Let's say right now, perhaps you've got some automation. A lot of us may be running that automation on our desktop. Not ideal, but it may be where we are in our evolution for automation right now. Perhaps we have it embedded into a continuous integration or continuous testing environment. Awesome, even better, so that on every deploy, maybe we're kicking off some or all of our test scripts, and we're running them in parallel, and maybe they're running on the build server, or maybe we've designated an additional test agent, so they're running on the test agent. But now I want to run 10, 20, 30, 50 of these things concurrently. That changes the execution profile of what we're doing. You need to make sure you have enough horsepower, that the machine you're running on, virtual or not, has enough memory, has enough processing power, possibly disk space, possibly fast enough disk in order for you to be able to write reports and write logs and access whatever it is that you need to have access to. And that it's in a sufficiently network-friendly location that reads and writes to disks aren't arduous from a processing standpoint either. Excuse me. Here is where we can really start to see some of the blemishes and coffee stains that we may have in our automation implementation that we just weren't aware of, because your timing profile changes. Things may run slower, they may run faster, but what's going to happen is the execution profile of how fast things work changes. So you may start seeing race conditions or unhandled race conditions in your individual test scripts that you didn't know existed. Why do we know they existed? Because the machines that we had been running on were sufficiently powerful enough or sufficiently weak enough that everything happened sufficiently fast or sufficiently slow that we never saw the race condition during our testing, and we missed it during review of our script. So we may start to see these intermittent failures. And I've lived through this where, hey, it works great on my desktop and it works great concurrently on my desktop at 10 in parallel. But then when you run 10 in parallel on this other server, we start to see intermittent failures because of timing issues. And then you have to figure out, how am I going to debug those things? Sometimes it's pretty straightforward. You see, oh, you know what? Our timeout here needs to be longer. Or, oh, wow, that thing can change in a different order than what we expected before. So now I have to handle it in either order. Some of them are pretty evident. Some of them are a little more insidious simply because they are hard to reproduce, and it's hard to get the debugging information that we need out of it because we can't reproduce it on our desktop. We can only reproduce it in a distributed environment, in a CI or some sort of DevOpsy kind of environment. So we have to run it out there a lot. But wait, I can't just make a change and then put it out there. I have to go through this build process, and there are code reviews and approvals. So it's not always straightforward. You may have to streamline some of your process to help you debug these types of issues. Now, there is some help out there for GUI testing, for app testing, like for mobiles. Managed grids and devices can help, where you have a choice. If you're going to go distributed, you may have to build out your own infrastructure in your data center, in your cloud, whatever. Or you can go to one of these partners that would manage a grid, like a Selenium grid or a Test Complete shared environment or something along those lines. There's a cost to that, but there are also ancillary features that you get, like recordings and other things that can help you debug these types of issues. So you have to look at the value, you have to look at the economics and decide what makes sense for you. And this, what it boils down to in most of my talks and boils down to here as well, is you have to be appropriate. What problem is it that you're trying to solve by parallelization? I want to run all of my stuff in parallel. The longest test script I have takes 1 minute and 43 seconds. So in 1 minute and 43 seconds, I'm going to know whether my deploy is good or not. Okay, that's awesome, but that's not feasible for most of us. Most of us don't have sufficiently deep pockets and a sufficient staff to be able to set up and maintain that. That's not going to be cheap for the most part, especially if we're talking about GUI testing or mobile testing. It's not feasible to do that. We have to go from everything in parallel down to, well, not everything sequential. There's a gray area in there, a sweet spot where we're going to get better off than we are, so that we can decide, is this still valuable for us? So when we talk about how fast does our run need to be, it needs to be fast enough. Well, what's fast enough mean? Well, that's going to depend. It's going to depend on the tolerance that you have to wait for that information to come back. What do I mean by that? Well, if I do a deploy and I want to run a set of automation scripts on that deploy to know whether or not it's worth a human being lifting a finger to go and do further interaction with it. Okay, cool. Now we know what our test set is. I want to run these 50 test scripts every time. And it takes an hour to do that. Well, that's too long. You don't want to wait an hour to find out if your deploy is basically on fire or not. So let's parallelize that. All right, that's one option. Another option is, well, you've got these 50 test scripts. Do you need to run all 50 to know if the deployment is on fire or not? Perhaps you can cut your number of test scripts down. Perhaps you can focus heavily on the API scripts, which run sub-second, and go easier on the UI, run those sequentially, and you still get the information you need without going through the potential headache of going parallel, of going concurrent, because there are headaches. There's work involved with going from sequential to parallel. But if you do decide, hey, I need to run faster, okay, and I need to go from 15 minutes to 10 minutes, maybe you can manage that yourself, maybe in your CI pipeline, your continuous testing pipeline. Well, you know what, if I run suite 1 and suite 2 in parallel, they're already apart from each other. They don't share the same downstream resources. I can just set that up to run those jobs concurrently, and then I'm done. I didn't have to do anything special about parallelizing the individual automation scripts and worry about threading and all these other things. I had a natural partition that I could just exploit. I still get some amount of concurrency. I reduce my total runtime because now I'm doing two things at once, but I didn't incur most or maybe any of the cost of going traditional parallel. So the idea here is don't over-engineer. Think about what it is you're trying to accomplish and what is the most valuable way to accomplish it. Start with what's appropriate and then evolve. So what do I mean by appropriate? Well, I worked for a company once, and we had I don't know, 3 or 4 machines that we ran our automation on. But then we needed to do this data center migration, and we needed to run a whole lot of stuff in parallel. But we weren't going to do that forever. It was just going to be during this particular migration. So we looked at VMs, we looked at this, we looked at that. So we went to the IT department and said, what kind of hardware do you have? And they said, well, we have these 34 or whatever it was, old PCs laying around. Core 2 Duos, maybe a couple of i5s in there. They're going to go to the recycler. You want them? Hell yeah, I want them. So we took them and we filled up a conference room with 34 whatever PCs, laptops. So there you see one of the tables. It was a little bigger table on the other side of the room, and then there was a round table in the middle, all with these laptops running concurrent automation. And we didn't set up a grid or anything like that. We knew which suites could be run in parallel because they were mutually exclusive of each other and what they were interacting with on the system. All we did was we basically wrote a remote shell script to kick these scripts off and then give us our data back. Was it free effort? No. Was it less than actually setting up a grid, setting up all of that, testing all those things, and then managing the grid? Absolutely 100%. 100%. It brought us the value that we needed, and it brought us the goal that we needed, which was to run this automation in this time window. And we didn't have to change the implementations. We didn't have to go threaded. We didn't have to worry so much about shared credentials. We had one set of credentials for each of the independent runs. The end. So be smart, and that's not an insult, I guess. Be judicious about how you implement this and why you're implementing these things. You may be able to meet your goal, your throughput goal, your speed goal, without having to go the whole way into pure concurrency and parallelization. So a few takeaways for you, and then I'll have time for some questions here. Remember thread safety. If the code's not thread safe, making it thread safe can be a huge effort. So that might not be something you want to undertake, and you want to look at a different way to get your execution speed down. Or maybe execution speed isn't really what the issue is. What you want is you want your information sooner. One way to do it would be increase your execution speed. There may be other ways to go about it as well. But look for thread safety if you believe you're going to be doing concurrency immediately or in the future. Appropriate environments. Remember, as you change what's running on a particular machine, virtual or not, it's going to change the performance profile, and therefore it is going to change how the scripts work. You may see some intermittent behavior that you hadn't seen before. So budget for that. Account for the fact that you're going to see behavioral differences, and some will not be pleasant. And you have to have appropriate data. If you don't have your data set up appropriately such that it is sufficiently unique and sufficiently segmented off across how the concurrent test scripts are going to work, then you're going to have intermittent failures. You're going to have data integrity issues. You may have data corruption. You may even screw up your data such that you have to completely rebuild it. And then remember, enough credentials. Most of our apps these days have some sort of login. You can't do very many things without being logged in. In some cases, you can't do anything without being logged in. So you have to have enough credentials that you're not going to clash, and you can keep off of each other's and your own toes. So here is my contact information. If you do want to get in contact with me, please check in. Also, I have a Slack channel here. It's D2_S1_Paul. And I do have time for questions. So Joel,